Bismillahirrahmanirrahim. Alhamdulillahirabbil wassalatu wassalamu ala asyrafil anbiya'i wal mursalin wa ala alihi wa sahbihi ajma'in. Okay, so in this session I would like to analyze. Okay, actually I would like to continue frame analysis, frame with Sidesway analysis. So we are going to learn how to analyze frame with one inclined column. Okay, one inclined column. So this is actually week number 5. So okay, let's start now. Okay, let's say we have one frame like this. Okay, say we have frame. This one inclined column. Okay, so here is fixed and okay, so this column, this frame, okay, this frame is Sidesway frame due to the geometry. So this frame is subjected to UDL and subjected to point load. Subjected to point load in this direction. And the forces is, this is 60 kilonewton per meter, and this is 250 kilonewton. 50 kilonewton. So A, B, C, D. Okay, A, B, C, D. We know that in frame analysis, we are going to actually learn how to calculate end moment. Okay, end moment for this, end moment for this. So we are going to analyze using four main steps. So there are two types of frame that we are going to analyze. Okay, there are two types of frame that we are going to analyze. Okay, it is okay. Okay, so this is non-sway frame, and Sidesway frame. The non-sway frame and Sidesway frame. So under non-sway frame, we have this. Okay, since the frame is tend to sway to right direction, okay, due to loading given, so we have to add restraining force. So this one is 250, this one is R. So this is R is 250, and we have DL is 60. DL is 60. Okay, let's say EI, 2EI, and EI. Okay, so length, get this. Okay, we get this. This, get this distance, and this distance. Okay, so we have here, this is 6 meter, this is 2 meter, and the height. Okay, total height is 10 meter. Okay, 10 meter, and the angle is given as 55 degree. Okay, 55 degree. So this will be Sidesway frame. This is for table number 1. Table number 1. For Sidesway frame, okay, for Sidesway frame, okay, for Sidesway frame, we have to remove loading. Okay, we have to remove loading, and R is actually applied in the other way direction. The other way direction. So this be R prime, actually R prime, because we are going to analyze, okay, analyze by assuming FEM for Sidesway frame. Okay. Okay. So this will be table 1. This will be table 1. Table, this one is table 2, table 1, table 1. Okay, table number 2 and table number 1. Okay, table number 1 is non-sway frame. It is properly restrained. Okay, and due to the artificial support that we put into C, okay, into C here, so it brings the restraining force. So in opposite condition under Sidesway frame, we will analyze okay, FEM based on assumption. Okay, so by applying principle of superposition, these are the two frame that we are going to analyze in frame with Sidesway analysis. Of course, this diagram we get from principle of superposition. Okay, so the diagram that we analyze under Sidesway frame is not the real one. That is why we apply R prime. Okay, so we will have two table. Okay, we have two table. Okay, we have to know that for each diagram, we are going to analyze number 1. Okay, number 1 is FEM. So here we have to calculate FEM due to loading. Okay, 2, we have to calculate FEM due to delta, and this one based on assumption first. Assumption. Okay, so that's the only different. Because next step, okay, whenever we want to calculate R value and R prime value, we actually do the same. Okay, we want to focus on this FEM first. Okay, so because in the table, the first moment that we put in the table is FEM. So, so we have to calculate FEM for both. So how to calculate FEM for AB? How to calculate FEM for AB? Sorry. How to calculate FEM for table number 1? Table number 1, FEM come from member BC only. BC only because BC has external loading on the member. Okay, so this one we have to calculate using simple formula. Okay, I believe everyone should know. So what we want to focus is to FEM due to delta. Okay, for this diagram. Okay, this diagram Sidesway frame. So we are going to analyze that one. So what we want is okay, what we want is this. Okay, so what we need to do is we have to find, okay, the delta for each member, where the delta is perpendicular. Okay, this will be delta 1 prime. Delta 1 prime. Okay, and then for column, okay, mark the 90 degree. Okay, this one. This will be delta 3 prime. So delta 2 is always vertical displacement. Okay, like this. So I now want to combine the delta. Delta. Okay. Okay, so we have delta 1, delta 2, delta 3. So from this we get, okay, delta 1 prime here, delta 3 prime, then delta 2 always belong to beam, delta 2 prime. So this is 90 degree. So it refers to this as this. Okay, refer to this as this. And refer to delta 2 prime. Okay, it is actually come from vertical displacement. Okay, vertical displacement. We measure from the lowest position of beam to the highest position of beam. So get this. Okay, so we have to make relationship. In order to calculate FEM due to delta. Okay, I don't focus FEM due to loading because I believe everyone should know. You just need to use formula and put the answer in the table. However, for FEM due to delta, what we need to do is we have to understand the concept of Sidesway frame. So under Sidesway frame, what most important is whenever we want to identify the delta, we must make sure that the delta must be perpendicular with member. And we mark the delta for column only because beam always follow wherever column move. Okay, so delta 1 prime is actually belong to AB. Delta 2 prime is actually belong to BC, and delta 3 prime is belong to CD. So now we are going to analyze, okay, FEM. Okay, FEM, remember FEM, we will actually do by assumption. So before that, we have to, let's say like this. We have column for AB, BC, CD. Okay, what is the formula? It is 6 times 6 times 6 EI. Delta 1 prime divide by length. Length is 10 meter. 10 square. For BC, it is 6 times 2 EI delta 2 prime. Delta 2 prime, okay, this one, delta 2 prime. Okay, for beam, divide by 6 square. Divide by 6 square. And what about CD? So CD, we need to calculate the length first. Calculate the length first. It is 2 meter and 55 degree. Okay, it is 2 meter. The 5. So we should use, this is H, or if this is Y, okay, it is tangent 55 equal to, sorry, what we want is L. So this H, this Y, okay. We want to calculate H value. So H using 55 degree is cos 55 equal to 2 over H. So we get H is equal to 2 divided by cos. It is 2 divided by cos 55. 2 divided by cos 55. Okay, 2 divided by cos 55 is 2 divided by cos 5, we get 3.487. 3.487. Okay, 3.487. This is actually L for CD. L for CD. So we will calculate by applying formula. It is 6 EI. This one we must use delta 3. Okay, delta 3 for CD. Okay, divide by 3.487 square. Okay, like this. So the next step is, okay. So the next step is, okay, we have to calculate the value. It is 6 divided by 10 square is 0.06. This one is 0.06. Okay, second one is 6 times 2 divided by 6 square. It is 12 divided by 36. It is 0.333. And we have another one. It is 6 divided by 3.487 square. is 0.49493. 0.493. Okay, so this one is EI delta 2. This one is EI delta 3. This one is delta 1, EI delta 1 prime. Okay, so what we need to do is we have to change this and this into EI delta 1 prime. Okay, then only we can compare and then calculate the value based on ratio. Okay, so we have to have this relationship. Okay, this one we have to identify the angle, and we have to identify relationship between delta 2 and delta 1 and delta 3 and delta 1. So the angle is given as 55. The angle is given as 55. Okay, it is like this. Okay, 9. Okay, this is the angle. 90 degree. So the angle is 55, which is located here. Five, 55. So we have actually the triangular which represent this. Okay, 55 is actually belong to 55 is actually belong to. So we have to find the angle. We have to find the angle. So this one is one triangular. One triangular. Okay, so we have to identify the angle. So 55, where is the position of 55 in the triangular? In this triangular. In this triangular. What is the 55 located? Where is 55 degree is located? This is 55 degree. So that is why this will reflect back to what to knowledge, the mathematical knowledge. So the mathematical knowledge as well as the basic structure engineering knowledge, where we have to identify this 55, okay, where is it under this diagram? Is it this or this? Where is 55? Where is 55? This one is 35. This is 55. Okay, 55 and 35. Okay, so we have to have relationship. For example, if you want to calculate to have the relationship between delta 1 and delta 1 and delta 2, we have to use tangent. We have to use tangent. Okay, let's say we are referring to the 55 degree. Okay, only 55 degrees. So what we gonna do is we will calculate the the relationship by using 55. It is tangent 55. It is tangent 55 equal to delta 1 prime divided by delta 2 prime. So this will produce, okay, it is 1 divided by tangent 55. It is 0.7. It is 0.7 delta 2 prime is equal to 0.7 delta 1 prime. Okay, so this value we have to substitute into this delta 2. So what we get is, it is 0.333 times 0.7, 0.7, okay, 0.7. So we get this as 0.233 EI delta 1 prime. Okay, EI delta 1 prime. So we have to do the same thing here, okay, to determine okay, the relationship between delta 3 and delta 1. So for delta 3 and delta 1, we have to use sine. We have to use sine. It is sine 55 sine delta 1 prime over delta 3 prime. So when we use sine, it is 1 divided by sine 55. So it is 1.22. 1.22 calculate times with 0.493. 0.493. So what we get is 0.6. 0.602. This one will be 0.602 EI delta 1. So we have 0.06 EI delta 1. Okay. So if we assume FEM for member AB is as negative 100, okay, please, okay, continue to find the value based on this ratio. So it is as simple as this. If 0.06 equivalent to 100, 0.233 equivalent to, it is 100 times 0.233 divided by 0.06. So it is 100 times 0.233 times divided by 0.06. So it is 388.33. So it is 388.33. Okay, so this is positive. Okay, this is positive. And then for the last value, so we have to calculate using interpolation. Using interpolation, it is 0.602. Okay, to calculate this value, it is 100 times 0.602 divided by 0.06. So this one we get, it is 1000. It is 1003.33. So it is negative 1003.33. Okay, why it is negative positive? Because of behavior. Because the frame the frame is like this. Okay, so A B is like this, FEM negative, FEM negative, because the angle is positive. Okay, so it is negative. Okay, for column, for another column, when move to this position, again it will, okay, we have this triangular, so measure the angle from original, angle is positive, so FEM angle is positive, FEM is negative, so that is why here I put negative. And for beam, is this position, so this one is beam, so the angle is negative angle, so FEM must be positive. So we get this one and this one and this one. So this is actually the value that we are going to replace, okay, in the FEM table. Okay, FEM table. So the most difficult part, so in frame analysis, is actually how to calculate FEM due to Sidesway, because it is actually based on assumption. So whenever we analyze another diagram called D diagram, where it is subjected by R prime, and due to R prime, the frame will tend to Sidesway without loading. So we have to actually apply FEM for all members. Because in this case, delta is not constant. So we have delta 1, delta 2, and delta 3 for AB, BC, and CD. Okay, respectively. So we find by using ratio, and then we compare with 100, the first assumption, FEM assumption, and we find another, okay, the remaining using calculation. So this is actually the guideline how we analyze end moment, fixed end moment in the second table, because we have two tables where it is actually similar. So the difference is only due to FEM, because FEM has two conditions. Due to external loading, we can calculate directly, and we have external loading, and we have delta where delta is unknown. So when delta is unknown, we have to assume FEM. 100 is the value that we assume. This is the value that we assume. And then using ratio, using interpolation, using trigonometry, okay, we have to calculate FEM for BC and FEM for CD. So these three are the value in the table. Okay, start from AB until DC. Okay, so I think that's all for this session. I focus on how we analyze FEM due to Sidesway. So I hope this will help you to understand about how we analyze frame with Sidesway. Okay, whenever there are three factors, which is L, EI, and delta. Okay, so either one of these, if different, means that we will get different FEM for BC